Alright, let's continue our investigation. And here we're going to continue working with the vertex form of the quadratic. We know it's quadratic because it's raised to the second power. And now we're going to focus on this number on the outside. So let's say I'm trying to add something on the outside after the exponent. I want to see what happens to the graph. So again, we can just plug in numbers and solve and graph them to see what happens. So I'm going to plug in -2 in for x. I'm going to do my work on the side. -2 squared is +4. +4 plus 2 gives me 6. So when I shift in plug in -2, out comes 6. Now I'm going to plug in -1, square it, and add 2. -1 squared is 1 plus 2. That gives me 3. Plugging in 0, I get 0 squared, which is 0 plus 2, gives me 2. Plugging in 1, 1 squared plus 2 is 3, because 1 squared is 1. And then finally, plugging in 2, 2 squared is 4, 4 plus 2 gives me 6. Remember, I expect to see symmetrical points on my graph, meaning I should see the same numbers in similar places as I go through. There should be a pattern. So I'll plot these points: -2, 6, -1, 3, 0, 2, 1, 3, and 2, 6. And let me graph them. So there's my function. Let's compare it to the original, and we'll use our transparency card. Make sure that you match up the y's and the x's. And let's see what's the difference here. So lining it up, it looks like this graph that I drew got shifted. And it looks like it was shifted up. So when I have that 2 on the outside, it moves the graph 2 spaces up. So the function of k, or value of k in this problem, was 2. And how did it compare to the original graph? It moved the graph up. So now the new coordinates of your minimum, because again the minimum is the point that's the lowest on this graph, are 0, 2. That's as low as you go. And this one, since it's positive, this one opens up. Let's work on the next one. For part 2, of the vertex investigation, and here we're subtracting 3. And by now you might be able to just predict what you think is going to happen to the graph, but I do want you to prove it by completing the table. So again, you're going to plug in your values and see what comes out. So here I'm going to plug in -3 squared minus 3. I'm plugging in -3 in for x. That turns into 9. 9 minus 3 is 6. Now I'm going to plug in -2 squared minus 3. -2 squared is 4. 4 minus 3 is 1. Now I'm going to plug in -1 squared minus 3. -1 squared is 1. Minus 3 is -2. Plugging in 0. 0 squared minus 3. 0 minus 3 gives me -3. Plugging in 1. 1 squared minus 3. 1 squared is 1. Minus 3 is -2. Plug in 2. 2 squared is 4. Minus 3 gives me 1. And then finally, plugging in 3. 3 squared is 9, minus 3 is 6. So again, I see that same pattern in my table where I'm seeing similar numbers pop up. Let me graph it nicely. So I have -3, 6, -2, 1, -1, -2, 0, -3, +1, -2, 2, 1, and 3, 6. Notice that again these have symmetrical or reflective properties, and that the points on this side are matched on the points on the other side. And then drawing my shape of my graph. Let's compare what happens this time. So here's my original. To get to the new one, I have to shift it down. And you probably predicted that based on what happened last time. So when numbers are on the outside after the exponent and you're subtracting them, you shift down. So the value of k in this problem is -3, and it moved the graph down. The new minimum in this graph is 0, -3. And this opens up. All right. Now you can move on to try seeing what happens when you have the value of h inside of the parentheses.